So I would like to talk about the variable speed of light model of spacetime. This was a model considered by Einstein before he went to general relativity. And even though it was not the model finally chosen, it's a very interesting model that gives a lot of insight into what problems and considerations were being made when trying to figure out space-time. The model starts with the background energy, and we're going to represent that with little squiggly balls, or which I would call space-time quanta. And the background energy is represented by the vibration of these quanta. And if you've ever done research about the background energy, it's actually extremely high, and at least when they could calculate it, and people are unsure why it's so high. But there's a lot of energy there to work with. So these space-time quanta are vibrating, and linear EM waves, light, and the other waves we know and love, radio waves, just ride on top of this quanta, moving at the speed of light. So these are theoretically vibrating at the speed of light, and electromagnetic waves just ride on top of them like a surfer rides a wave on the ocean. And if that was all there was, we wouldn't be here. But somehow these EM waves get converted into matter. And the process, the most simple process by which that happens is called pair production. So you get two high energy EM waves, usually gamma waves, I believe, that meet at a nucleus or somehow are brought together, and they create an electron-positron pair. And I'm going to draw that as kind of two oppositely configured squiggly entities, okay? Now, what that represents is the linear EM waves somehow being converted into circular waves. In other words, waves that circular stationary or circular standing waves that have a new set of attributes that make them, at least from our perspective, much more interesting, and turn them into matter. So this one might be, let's call it the electron, so the E minus, and we'll call this one the positron, so that's E plus. Okay. The attributes that they have are, obviously they have charge. They have continuous isolated charge versus an EM wave, which is fluctuating wave, because it goes from positive, negative, back and forth. They have spin 1/2. They both have spin 1/2, although just like the charge, the spin 1/2 for the electron is the opposite of the spin 1/2 of the positron. And they have, as part of the spin, they have exclusionary properties, which means they bump into each other. They can't just pass over each other. When two electrons meet each other, they repel. And not just for the electric charge, they can't occupy the same space because of the Pauli exclusion principle, and that allows you to build things with them. That's what makes them matter. They also experience time, okay? And time is just the rate at which they're vibrating in the space-time, or creating circles. Now, the exact mechanisms, it's interesting to look at some of the theories behind the mechanisms by which the electromagnetic waves are converted into standing waves. Two more interesting ones that I'm aware of are when the electric waves, the EM waves are sufficiently strong enough and all the conditions are right, they create a nonlinearity. They stretch the space-time beyond what it can normally do and create a nonlinearity. Another example of a nonlinear wave is a breaking wave on the beach. So when a normal wave is a linear wave, but when it starts to break on the beach, you get a white top, a white bubbly top. That's a breaking wave. That's a nonlinear wave, and those waves exhibit some of these properties. Two breaking waves will smash into each other and distort each other, while two linear waves out deep in the deep ocean just pass through each other. Another example is a Bragg diffractor, which is a type of crystal that's constructed in a way that creates nonlinearities. And so light, when it goes through these Bragg diffractors, can form standing waves in the crystal. The other theory is that these waves become matter is it's called the quasical theory, is that the electromagnetic waves start performing rotating figure eights, and I'll try to put a picture of that. Basically, what happens is when you get a rotating figure eight, which is effectively what happens with spin 1/2, takes 2 revolutions to complete the cycle, which would be a figure eight. But the rotating figure eight keeps one side of the electromagnetic wave on the outside and the other side of the other charge on the inside. So in one configuration, the positive part of the electromagnetic wave is always on the outside. That creates a positron. And the other configuration, the negative part of the electromagnetic wave is always on the outside. And that creates an electron. This is a very interesting theory. Again, I'll put up a picture and maybe put some links. And if you're at all interested in this, I would go look at the Quasical website, because it really has some, it really makes a lot of sense. Let's just put it that way. And here we have the quacycle model of the electron pair production. The linear spiked lines, flat ones, are regular light waves, EM waves. And then the double circular sections are the electron and positron. And the basic thesis is the linear LM wave is converted into a bicircular matter wave, and with one wave being inside out, with each wave being, I guess, inverted from the other, where the negative points out for the electron and the positive points out for the positron. It's a very interesting model. And here's just another perspective of the linear normal EM wave, light wave, converting into the double circular electron or matter wave. And so what's interesting is the double circular model gives you the spin 1/2. So you have to rotate twice in order to get back to your starting position. So it takes care of that. And then while it's circling, it becomes a standing wave, which is what we would associate with matter. And so it fills in it checks a lot of the boxes for the EM wave to matter conversion process. So how do we go from these matter particles to gravity and the bending of light and the curvature of space-time and all that stuff? Well, it's pretty simple, actually. Let's put a matter particle on the table here, and then we'll put it inside a space-time quanta. Well, the most simple way to look at it is that once you reach this nonlinearity or circular configuration of the electromagnetic wave, it somehow puts a strain on the space-time quanta or the background energy. This could be due to the nonlinearity, making it space-time nonlinear, or could be due to something else. And another way to phrase that, the way I like to phrase it, is it causes the space-time to be a little bit stiffer. So it vibrates. It's a little bit harder for it to vibrate, so it vibrates more slowly. The more technical terminology for this would be that it, and I don't know why it increases. To me, it would be decreases, but it increases the electromagnetic permittivity and permeability. And that's out of Maxwell's equations. And also Feynman looks at that for a long time as well. But anyways, the electron will vibrate, or the matter will vibrate at a slow rate, and also experience time more slowly. Now, the way it creates gravity is that the space-time quanta are all adjacent to one another. So there's a series of space-time quanta surrounding the matter-filled space-time quanta. And because they're next to a slower vibrating space-time quanta, they'll vibrate more slowly as well, because there's just less flexibility in the space-time. They have a stiffer piece of space-time next to them that impedes their ability to vibrate. So these ones will be slightly slower vibrating than the center one. Similarly, there'll be another set of space-time quanta surrounding that one. And they also will be vibrating more slowly because they are next to a slower based space-time quanta, but it won't be as much because each time there'll be less stiff space-time quanta next to them. So these will just be a little minus, not a big minus. So let's put a double minus on the inside ones. The inside ones have a double minus. These only have a single minus. Okay. And what this creates is a gradient where you have time flowing at a certain rate for the inner circle, and then time flowing for another rate for the outer circle. And this creates a time gradient, which is what we associate with the waterfall or the flow model of space-time on gravity, or gravelocity. So since light going through a gradient will slow down if it's going through a non-even slow down of space, just like light going through water slows down and it bends. Light going through a gradient of speed, I guess, or a medium that has a gradient of speed will curve as it goes through. And that's the effect of gravity. And similarly, obviously, if you had a piece of matter, some matter here, a free matter, okay, it will also experience a gradient of vibration. And as each time it circles around, it will curve into the slower moving space-time, and that'll cause the matter to actually fall into, the rest of the matter. And that's the cause of gravitational attraction. A great example of this, or great metaphor for this, is a tank of water. Okay. Where you put sugar sugar in the bottom, and then allow it to slowly dissolve into the without stirring it into the tank, into the water. And this creates a gradient of sugar concentration, of sugar solution, where the solution is more sugary at the bottom and gets less and less sugary as you go up. Since sugar water transmits light more slowly because the sugar causes the light to polarize and spin, this creates a gradient at the flow of light through the water. And if you shine a laser beam or anything else through that tank of water, it will bend just like it's going through gravity. I'll try to put in an example of that. Finally, and here we have an example of laser light bending through water with a sugar gradient. Sugar's at the bottom and it's dissolved unevenly.
The light bends because it travels at a different speed depending on whether it's higher or lower in the tank. And that's just like gravity traveling through a gravitational gradient created by matter.
I guess that's about it. Except there's one other thought. I like to call the matter that we are and that we're normally encounter negative matter, and I call it negative matter because this matter we slow down space-time. We have a negative effect, a drag effect. I call it maybe cosmic glue. We're cosmic glue. There could be perhaps another form of matter, just like this antimatter and matter. There could be a positive matter which I would call cosmic grease, which would allow space-time to vibrate more quickly. And this would have the effect of repelling light and creating a positive gradient. So if light went through that, it would go away from the center. Or let's do it this way, so compare. Go away from the center if there's a positive gradient. Now, we don't have really any examples of that matter that we can touch and feel. However, we do have dark energy. And dark energy is causing everything to move apart. And one possibility for that would be cosmic grease or positive matter. And that would be a type of matter that's causing space-time to vibrate more quickly and causing everything to separate. So maybe at the time the universe was formed, there was positive matter, negative matter. Negative matter all groups together, and all the positive matter pushes apart. And that's why we have what we have today, where we have lots of concentrated galaxies and then space pushing everything apart. Just a thought. I guess that's it. But that is the variable speed of light model of space-time. And the reason why it's variable is because theoretically light travels more slowly as it gets into a gravitational field with matter. Now, the reason why they don't like that, the relativists didn't accept that, is because what happens is, yes, the light is traveling more slowly, but also time's traveling more slowly. So it's still, from the point of view of someone on the planet Earth, it's still traveling at, so many meters per second, because my seconds slow down. And, that at that point, because of semantics, the reality is time is slowed down and light slowed down. So the light is traveling more slowly, just as it does when it's traveling more slowly through the sugar water gradient. The only difference is the sugar water doesn't slow down time, it just slows down light. So you can observe the difference, whereas you can't really observe the difference because your clock is slowed down just as much as the light is slowed down. Anyways, okay, thank you.